Right now, you're staring at a galaxy containing 1 trillion stars hurtling toward us at 250,000 miles per hour. That galaxy is Andromeda, a galactic titan that dwarfs everything we believed possible, stretching across 220,000 light-years of space, making our own Milky Way look small by comparison. Tonight, we're taking you on a journey through Andromeda's true scale, from its blazing core to its invisible dark matter halo that extends 6 times farther than we ever imagined, through star-forming regions larger than entire galactic arms, past ancient globular clusters and spiral arms containing more stars than we can count. If you're ready to discover just how massive our cosmic neighbor really is, hit that like button and subscribe, because we're about to explore the unimaginable. Let the journey begin. Far above the night sky, a faint smudge of light marks a truth that has always been with us. That smudge is Andromeda, our nearest galactic neighbor. For centuries it was a mystery, for decades it was a question, and only recently have we begun to uncover its true scale. At first glance, Andromeda hardly seems worth noticing. If you step outside on a dark autumn evening, away from the glow of city lights, you might mistake it for a tiny patch of cloud. It doesn't twinkle like the stars, nor blaze like a planet. It simply lingers there, ghostly and soft, as though painted onto the darkness with a single brushstroke of light. And yet, that faint blur holds more stars than our entire galaxy. What appears as something small to the human eye is in truth a sprawling cosmic giant. For most of human history, people had no idea what they were seeing. Ancient cultures folded Andromeda into their myths, imagining it as a divine sign, a heavenly presence, or a fragment of mist hanging in the heavens. To the Greek storytellers, it became part of a legend, the chained princess Andromeda, rescued by Perseus. They could not have known that this delicate blur was not a star, not a cloud, but a galaxy of unimaginable scale. It wasn't until the age of telescopes that Andromeda revealed its secrets. Early astronomers peered at it through glass lenses and mirrors, calling it a nebula, a word that means cloud. They thought it might be a strange patch of gas inside our own galaxy. To them, the Milky Way was the entire universe. The idea that there might be other vast systems of stars, millions of light years away, was almost unthinkable. But the truth was waiting, carried on the faint light that had travelled across the void for millions of years just to reach us. That light, soft as it seems, began its journey long before humans walked the earth. When the photons that touch your eyes tonight first set out, continents looked different. Ice ages rose and fell. Entire species evolved, thrived, and vanished. Across the span of deep time, that light travelled unbroken, never slowing, never pausing, until finally arriving here, to your moment of quiet reflection. When scientists finally measured Andromeda's distance, the results were staggering. This faint smudge was not within our galaxy at all, it was far beyond, a separate island universe. The discovery shattered our sense of place. No longer could we think of the Milky Way as everything. Instead, we were just one among many galaxies, drifting in an ocean of billions. Andromeda invites us to remember the scale of the universe. It reminds us that what looks small may, in truth, be vast beyond comprehension. It whispers that we are part of something much larger, something still unfolding. That faint blur of light in the night sky is not just an object to observe. It is a cosmic invitation, a reminder that our story belongs to the greater story of the universe itself. Long before telescopes, ancient sky watchers noticed the strange cloud-like glow in the constellation of Andromeda. They had no idea they were staring across millions of light-years at a galaxy larger than our own. For them, the night sky was a living storybook. Every glittering point of light became a character, every faint blur a symbol. To the peoples of the Mediterranean, the pattern of stars surrounding this mysterious glow became the tale of Andromeda, the chained princess, bound to the rocks as an offering to a sea monster, only to be saved by the hero Perseus. The heavens served as a canvas where myth and meaning were painted across the void, and while their stories could not reveal the galaxy's true nature, they captured something profound, that this faint glow held importance, that it was more than ordinary starlight. Imagine what those ancient observers must have felt. With no knowledge of galaxies, no understanding of light years, they gazed at Andromeda with wonder. The human eye, unaided by technology, can see just the central brightness of the galaxy, the concentrated glow of billions of distant suns blended together. It must have seemed ethereal, a cloud too permanent to be weather, too delicate to be a star. They could not know that what they were truly seeing was the combined light of worlds uncounted, each sun as real as our own. For centuries, Andromeda remained shrouded in uncertainty. Ancient Chinese astronomers noted it in their sky charts nearly 1,000 years ago, cataloguing it as a cloud among the stars. Medieval Persian astronomers mentioned it as well, recording its hazy appearance without comprehension of what it was. Different cultures across the world all shared the same mystery. None could know that the faint blur they described so carefully was not merely nearby, but unimaginably distant. There's something humbling about this. When you look up at Andromeda today, you're joining a lineage of observers stretching back through all of human history. You see the same misty glow that shepherds once saw above desert horizons, that sailors glimpsed while navigating by the stars, that storytellers wove into constellations and legends. Across time and across cultures, the human experience of Andromeda has been one of quiet awe. And yet, the true scale of what they were witnessing was beyond even the boldest imagination. To call it a cloud was not entirely wrong. Andromeda does contain vast clouds of gas and dust. But to recognize it as a galaxy, that leap required centuries of science, instruments, and courage to reimagine the universe itself. The ancients gave Andromeda a name and a place in their myths. We, standing on their shoulders, can now give it context in the grand structure of the cosmos. Even before its secrets were revealed, Andromeda was already calling to us. It was a puzzle piece waiting to be placed. It whispered to every observer, "There is more out here, more than the stars you know, more than the world beneath your feet." The ancients did not have the answers, but they had the questions, and those questions were enough to carry their gaze upward, night after night, to wonder at the faint smudge in the sky. The first glimpse, through ancient eyes, of the galaxy next door. Andromeda is 2.5 million light-years away. Even at the speed of light, the journey takes longer than humanity has existed, yet its light still crosses the void and reaches our eyes, carrying whispers from a past we can barely imagine. When we speak of a light year, it can sound deceptively simple. The distance light travels in a year. But light is the fastest thing in the universe. It races at 186,000 miles per second. So swift that it can circle Earth 7 times in a single heartbeat. Stretch that speed over 12 months, and you have a unit so vast it defies our everyday sense of distance. Multiply it by 2.5 million, and you begin to glimpse the scale of the separation between us and Andromeda. Consider this. If you could drive a car at highway speed, never stopping, never resting, you would arrive at Andromeda, not in centuries, not in millennia, but in 30 billion years. By then, Earth itself would be long gone. The continents would have shifted into strange new shapes, the sun would have swollen into a red giant, and our solar system would be unrecognizable. Even at such a pace, the galaxy next door would remain impossibly out of reach. And yet, the light does reach us. Every night, photons that began their journey before our species existed find their way into our atmosphere. When they finally touch your eyes, they carry with them a message written in the ancient past. The glow you see from Andromeda tonight began its journey when early ancestors of modern humans were not even a thought of evolution. When the world was ruled by creatures long extinct, looking at Andromeda is not like gazing at the present. It is like gazing through time. The void between us is nearly empty, but not completely so. It is filled with sparse atoms of hydrogen, with faint magnetic fields, and with the unseen presence of dark matter. But compared to the density of our solar system, it is silence, a silence so deep that entire galaxies can drift within it without ever touching. For us, the space between stars is daunting. For Andromeda and the Milky Way, that void is a mere gap to be crossed in the cosmic dance of galaxies. In fact, Andromeda is not drifting away from us as most galaxies are. The expansion of the universe is stretching space itself, pushing distant galaxies farther apart. But Andromeda is close enough and massive enough that gravity has overcome that expansion. Rather than fleeing, it is slowly approaching. Across those 2.5 million light-years, it creeps toward us at 250,000 miles per hour, pulled by the same universal force that keeps Earth in orbit around the Sun. The distance, though vast, is shrinking. So when you look at Andromeda, you are seeing both the past and the future. You see light from long ago, but you also see a galaxy on its way to us, destined to reshape the night sky billions of years from now. It is a reminder that the void is not permanent. It is a bridge, stretched across space and time, connecting two galaxies that will one day become one. Inside Andromeda live nearly 1 trillion stars, far more than our Milky Way. Each star could host its own worlds, its own systems, its own possible stories of life. When we say Andromeda is large, we mean unimaginably so. 1 trillion is a number that slips away from the human mind. We can picture a dozen. We can stretch our thoughts to 1,000. 1,000,000 feels immense, and 1,000,000,000 borders on the incomprehensible. But 1 trillion? To count to 1 trillion, naming one star every second, would take you over 31,000 years without rest. Yet that staggering figure is only the beginning of Andromeda's scale. Each star is not just a point of light, but a sun in its own right, blazing with energy, shaping space around it, and perhaps hosting a family of planets. Some of these stars are small dim red dwarfs, the most common type in the galaxy. They burn slowly, using their fuel with incredible thrift, and may shine for trillions of years, far longer than the universe has even existed so far. Others are massive blue giants, burning with a brilliance so fierce they live for only a few million years before collapsing in violent explosions. Between these extremes lie stars like our Sun, stable and steady, providing light and warmth for billions of years. Imagine the diversity of skies across those worlds. On one planet, a faint red star might cast a dim, eternal twilight, while another world might orbit a double sun, experiencing two shadows at once. Still another might circle close to a blue-white giant, its days flooded with piercing light, its nights glowing faintly from the afterglow of its furious sun. Multiply these possibilities by 1 trillion, and you begin to feel the enormity of Andromeda. Many of Andromeda's stars are ancient. The galaxy itself formed billions of years before Earth ever took shape. Some of its suns were shining when our solar system was only a swirling cloud of gas and dust. Others are newborn, still cradled in the glowing arms of nebulae where gas collapses into flame. This mix of the old and the young paints Andromeda as a place of constant renewal, stars dying, scattering heavy elements into space, and new stars rising from the ashes. Where there are stars, there may also be planets. If even a fraction of Andromeda's suns host worlds, then the galaxy could contain trillions of planets. Some barren, some strange, and perhaps, just perhaps, some alive. The sheer numbers tilt the odds in favor of life existing somewhere, even if we never see it. When we call Andromeda large, we are not only describing its size in light years, we are describing the weight of possibility contained within it. 1 trillion stars, each one a story waiting to be told. Some of those stories may mirror our own. Others may be stranger than we can imagine. All of them together create a cosmic library written in light, stretching across the sky, reminding us that our sun, as powerful as it feels, is just one among countless others. Andromeda's size cannot be measured by visible stars alone. Wrapped around it is a vast halo of dark matter, stretching millions of light years. This invisible structure is larger than everything we can see combined. Dark matter is one of the greatest mysteries in science. It neither shines nor reflects. It does not absorb light. To our eyes, it is utterly transparent. And yet, it outweighs every star, every planet, every nebula, every glowing spiral we see through our telescopes. If the luminous disk of Andromeda is like a lantern shining in the night, then its dark halo is the unseen room that holds it. Vaster, emptier, and yet far more massive. Astronomers discovered dark matter not by seeing it, but by noticing its effects. When they measured how fast Andromeda's stars orbit the galactic center, they found something strange. The stars at the edges of the galaxy were moving far too quickly. The visible matter, the trillion suns, the glowing gas, the radiant arms, simply wasn't enough to hold them together. Something else, something unseen, was providing the extra gravity. That invisible mass became known as dark matter. And so, Andromeda's true boundary is not the graceful spiral we see through telescopes. It is something much larger, a sphere of unseen mass, a halo extending 2 million light-years across. Imagine that for a moment. The visible galaxy may stretch 100,000 light-years from side to side, but its dark halo is 20 times larger, enveloping it in a cocoon of gravitational power. Within this halo, stars and galaxies move like leaves caught in a hidden current. The dark matter shapes their paths, guiding their motion, even though they cannot see it. It is like wind shaping the flight of birds, invisible, but undeniably present. We live in a universe where most of the matter is hidden, where the bright galaxies we see are only the tips of vast, unseen structures. This halo also connects Andromeda to the larger cosmic web. Along invisible filaments of dark matter, galaxies cluster together, bound across distances so immense they defy comprehension. Andromeda itself is not an isolated island. It is a node in this grand web. Its dark halo merging, overlapping, and tugging against the halo of our own Milky Way. This invisible scaffolding ensures that in 4 billion years, the two galaxies will meet. To look at Andromeda and imagine its dark halo is to accept a strange truth. What we see is only a fraction of reality. The stars, as dazzling as they are mere tracings of something larger. The true bulk of the galaxy is invisible, a shadow realm of mass and gravity that dwarfs the shining disk we admire. And so Andromeda becomes a reminder of humility. What we can see is not all there is. The universe is not defined only by light, but by what lies hidden beyond sight. Its greatest structures are built not from brilliance, but from silence. For years, astronomers underestimated Andromeda's width. New telescopes, mapping techniques, and star surveys revealed the shocking truth. Andromeda's boundaries extend twice as far as we once believed. For a long time, our picture of Andromeda was like looking at a mountain through morning fog. We could see its outline, but the true scale remained hidden. The central core glowed brightly through telescopes, and the spiral arms unfurled like ribbons of starlight. But where, exactly, did the galaxy end? Our instruments were limited, our measurements uncertain, and so Andromeda was drawn smaller in our cosmic maps than it truly deserved to be. The challenge lies in the nature of galaxies themselves. Unlike planets, they do not have sharp edges. A planet like Earth is a sphere with a clear boundary, air above, ground below. But galaxies fade gradually into the dark. Their stars thin into halos, their gas spreads into clouds, their influence stretches invisibly through gravity. To declare where one ends and the void begins is as much philosophy as science. For decades, astronomers measured Andromeda's bright central regions and assumed that was the galaxy. But as technology improved, faint stars once invisible to human eyes began to appear. Deep surveys revealed streams of stars stretching far beyond the luminous arms. Some of these streams were remnants of smaller galaxies consumed by Andromeda's gravity. Others were stars orbiting at extraordinary distances, still bound to the galaxy's mass. Each new discovery pushed Andromeda's edge farther outward, redrawing the map of our cosmic neighborhood. The turning point came with wide-field telescopes capable of imaging enormous swaths of sky at once. Instead of focusing on the glowing heart, astronomers could finally trace the delicate halo of stars surrounding it. What they found was astonishing. Andromeda wasn't just 100,000 light-years across, as once thought. Its true stellar disk and extended halo stretched closer to 200,000. And when the influence of its dark matter halo was considered, the galaxy's effective boundary reached millions of light-years. This revelation changed not just our perception of Andromeda, but of our own place in space. The Milky Way and Andromeda are closer in size than once believed, their halos already overlapping. In a sense, the two galaxies are already touching, their outermost stars and invisible matter entwined. The future collision is not something that will begin billions of years from now. It has already begun in the faint outskirts, where gravity has linked them into a slow, inevitable embrace. Each new measurement humbles us. Every advance in technology reveals the universe to be larger, stranger, and more interconnected than we imagined. What was once thought of as a tidy nearby spiral has expanded into a giant whose reach brushes against our own galaxy. The lesson is simple and profound. Our maps are always incomplete. The cosmos is always larger than the lines we draw around it. Andromeda's expanding measurements are not just numbers on a chart. They are a reminder that reality itself is deeper and wider than we can see, and that every faint glow in the night sky may conceal a story far greater than we have yet dared to imagine. Around Andromeda float long rivers of stars, remnants of smaller galaxies it has absorbed. These stellar streams trace its violent history, showing us that galaxies grow by devouring others. If we could dim Andromeda's bright core and arms, the hidden truth would become clear. Spilling outward from the galaxy are faint, curving arcs of light, trails of stars stretched thin across millions of years of orbit. But deep surveys, using telescopes designed to capture the faintest glimmers, reveal these ghostly rivers. They are fossils written in starlight, evidence of past collisions and conquests. Each stream tells a story. Long ago, a small dwarf galaxy wandered too close to Andromeda. Its stars, once held together by their own gravity, began to feel the far stronger pull of the galactic giant. Slowly, over billions of years, its structure unraveled. These orphaned suns are no longer part of their parent galaxy. They are bound forever to Andromeda's gravity, woven into its growing mass. This process is known as galactic cannibalism, and it is not rare. Galaxies grow by consuming their smaller neighbors. The streams we see today are the leftovers of this process. Delicate filaments marking where galaxies once lived. Some streams encircle Andromeda in vast loops. Others plunge straight through its halo, like arrows frozen in time. Together, they form a record of violence and transformation. What's remarkable is how gentle the violence appears when viewed on galactic timescales. A single collision can take billions of years to unfold. From our perspective, the streams seem frozen, hanging in place. But if we could speed up time, the arcs would swirl and shift, wrapping around Andromeda's center, mixing into its disk, until eventually the original structures disappear. What remains is a larger, stronger galaxy, enriched by the stars it has consumed. Some of these streams are thought to be remnants of galaxies once, much like our own dwarf companions, the Magellanic Clouds that orbit the Milky Way. Just as Andromeda has swallowed dozens of smaller systems, so too will the Milky Way. In fact, the faint rivers of stars stretching through Andromeda's outskirts mirror the streams already discovered around our own galaxy. Both giants are sculpted by the same process, caught in an endless cycle of creation through destruction. These rivers of stars are also important clues for astronomers. By tracing their arcs and mapping their motion, scientists can measure the shape of Andromeda's dark matter halo. The stars act like breadcrumbs, marking the contours of gravity itself. So, when we look at Andromeda and imagine these hidden streams, we are not seeing a static picture. We are seeing motion, history, and destiny, all captured in fragile threads of light. They remind us that galaxies are not eternal monuments, but living systems, growing, colliding, and reshaping themselves across the endless span of cosmic time. At the center of Andromeda waits a monster, a black hole over 100 million times the mass of our Sun. It anchors the galaxy, swallowing matter and shaping the stars that swirl around it. From a distance, Andromeda's core glows with a soft, concentrated brilliance. To the human eye, it appears calm, like a lantern burning steadily in the night. But hidden behind that gentle glow is one of the most extreme environments in the universe. The supermassive black hole at its center bends space itself, its gravity so intense that not even light can escape once it crosses the invisible boundary known as the event horizon. And yet, this black hole is not just a destroyer, it is also a creator of order. Without it, Andromeda's inner stars would drift chaotically. Instead, they orbit in elegant, predictable paths, like dancers circling an unseen conductor. The very stability of the galaxy owes itself, in part, to this invisible anchor. Around the black hole lies a region of turbulence. Gas clouds spiral inward, heating as they fall, glowing with X-rays and radio waves that astronomers can detect from Earth. Sometimes, the black hole slumbers, swallowing little. At other times, it awakens, devouring matter at such a rate that it releases jets of energy stretching thousands of light-years into space. These eruptions are brief on cosmic timescales, but they leave scars in the galaxy, reshaping the regions around the core. Stars that venture too close are torn apart in tidal disruption events. Cosmic catastrophes where gravity stretches a star like taffy until it disintegrates, its remains swirling into the black hole's maw. These rare outbursts flare like beacons, revealing the monster's appetite. In a galaxy of 1 trillion stars, the black hole's hunger may seem small, yet across billions of years it consumes enough to grow ever more massive, changing Andromeda's balance in the process. The sheer scale of this central giant is difficult to comprehend. Our planet, along with every other world in the solar system, would lie inside its shadow. That is the weight of 100 million suns compressed into a single point, a gravitational abyss so deep that time itself stretches and slows in its presence. Andromeda is not unique in harboring such a beast. Nearly every large galaxy we observe seems to shelter a supermassive black hole at its heart. The Milky Way's central black hole, Sagittarius A*, is enormous, but Andromeda's is far greater, a reminder that our neighbour is larger and more powerful than we once believed. The supermassive heart of Andromeda beats in silence, unseen but undeniable. It is a paradox, a void that gives structure, a destroyer that sustains order. As we trace the spiral arms outward, we must remember that at their centre lies not a glowing sun, but an invisible giant, patiently shaping the fate of the galaxy around it. From a distance, Andromeda reveals delicate spiral arms. But up close, these arms are vast highways of stars, gas and dust, wrapping around a galactic disk hundreds of thousands of light-years across. The arms are not solid structures, as their graceful curves might suggest. Instead, they are patterns in motion, regions where matter gathers, compresses, and ignites with the birth of new stars. To an observer within Andromeda, these arms would not appear as luminous streaks across the night sky. They would appear as crowded neighborhoods, where bright clusters of young stars shine amid colossal clouds of gas. For a traveler drifting through them, the arms would feel less like static features and more like living, shifting rivers of light. These arms extend outward from the galaxy's bright core, sweeping around in long arcs that span hundreds of thousands of light-years. Within them are nurseries where new suns are born, star clusters that sparkle with youth, and remnants of ancient stellar explosions. They are places of both creation and destruction, where stars ignite and stars die, all woven into the endless cycle of galactic life. The spiral arms also act as engines of structure. As gas clouds drift into these dense regions, gravity compresses them until nuclear fusion begins, lighting new suns that flood the surroundings with energy. These newborn stars are often massive and hot, burning with fierce blue-white brilliance. They live fast and die young, detonating in supernovae that seed the galaxy with heavy elements, oxygen, carbon, iron, the building blocks of planets and life. In this way, the spiral arms are like cosmic forges, continuously shaping the galaxy's chemistry. But the arms are not permanent in the way mountains or oceans are on Earth. They are more like waves traveling across a sea of stars. As material moves through the galaxy, it slows and compresses in certain regions, creating the illusion of a spiral shape. Stars and gas flow into these arms, linger for a time, and then drift back out into quieter inter-arm spaces. The spiral persists, not because the same stars remain there, but because the pattern endures, like traffic jams on a cosmic highway. Seen from Earth, Andromeda's arms are breathtaking. Even with the naked eye, their combined light forms the faint smudge in our night sky. Through telescopes, they reveal strands of glowing nebulae, clusters of young blue stars, and dark dust lanes tracing intricate curves. Each feature hints at the scale of the structures. Clouds larger than solar systems, clusters brighter than thousands of suns, and voids carved by ancient supernova blasts. To imagine walking across one spiral arm is to imagine an impossible journey. It would take tens of thousands of light years, even at the speed of light. And yet, the arms themselves are not rare. They are one of the defining features of spiral galaxies across the universe. Andromeda's arms remind us that beauty in the cosmos often arises from motion, from flow, from cycles of creation. They are delicate from afar, but up close, they are colossal, dynamic highways of matter and energy. Between Andromeda's shining stars lie enormous clouds of interstellar dust. These cosmic veils hide the galaxy's deeper secrets, absorbing starlight and reshaping the glow we see from Earth. To our eyes, the galaxy appears as a faint haze, but telescopes reveal dark streaks woven through its spiral arms. These are not empty spaces, but curtains of fine dust, grains smaller than smoke particles, scattered across light years of space. Though delicate in size, their collective presence is vast enough to obscure entire regions of the galaxy. To astronomers, they are both a challenge and a treasure. Dust changes how we see Andromeda. As starlight passes through these clouds, it dims and reddens, a process known as interstellar extinction. Brilliant blue stars can appear faint and orange, their true luminosity hidden behind the veil. This trick of cosmic dust once made Andromeda appear less massive than it really is. Only with the help of infrared and radio telescopes, which can pierce the obscuring clouds, have we begun to see the galaxy in its full detail. But dust does more than block, it also creates. Within these clouds lie the seeds of new suns. Dust grains mingle with cold hydrogen gas, forming dense molecular clouds. Over millions of years, gravity gathers the material into clumps that collapse and ignite into newborn stars. The veils of Andromeda are, in truth, nurseries, places where the next generations of light are being woven from shadow. The scale of these dusty regions defies imagination. Some stretch across hundreds of light years, forming intricate lanes that trace the spiral arms like strokes of ink. Others cluster in knots and filaments, glowing faintly with the reflected light of nearby stars. Seen through powerful telescopes, these structures resemble cosmic sculptures, twisting columns, sweeping arcs, and delicate webs carved by stellar winds and radiation. From Earth, the dust gives Andromeda a layered beauty. In visible light, the galaxy appears mottled, with luminous bands broken by dark streaks. In infrared, those same dark regions shine, warmed by the faint glow of starlight trapped within. To study Andromeda is to study it through multiple windows, each wavelength peeling back a layer of the veil, revealing a different face of the galaxy. These dusty veils are not unique to Andromeda. The Milky Way is also threaded with such clouds, visible in the great dark rifts across our own night sky. But in Andromeda, The veils are especially striking because we see them from the outside, spread across the canvas of a spiral galaxy tilted nearly edge-on. They remind us that what looks like darkness in space is often the birthplace of light. So when we gaze at Andromeda and notice the shadows breaking its spiral glow, we are not seeing emptiness. We are seeing potential. We are seeing the raw material of stars, the quiet architecture of creation, hidden behind curtains of dust. These veils obscure, but they also promise that in the heart of every dark cloud, new suns are waiting to be born. Within Andromeda's arms, massive molecular clouds collapse under their own gravity. Here, stars are born by the thousands, igniting like cosmic candles inside dark nebulae. To the human eye, these regions appear as shadowy voids, blocking the light of stars behind them. But in truth, they are bustling with activity. Hidden within the darkness are cocoons of gas and dust, denser than the space around them, slowly gathering mass. Over time, gravity pulls the material inward, squeezing tighter and tighter until pressure and temperature rise to extraordinary levels. When the core grows hot enough, nuclear fusion ignites, and a new star is born. The process is not instantaneous. It takes millions of years for a cloud to collapse and ignite. Only infrared telescopes can detect its faint warmth. As the newborn star grows stronger, it pushes away the surrounding material with powerful stellar winds. The veil lifts, revealing a young sun blazing for the first time against the cosmic night. Multiply this process across Andromeda's spiral arms, and you find not a few stars being born, but thousands, entire clusters igniting like strings of lanterns strung across the galaxy. The most massive of these newborn stars burn fiercely, flooding their surroundings with ultraviolet radiation. They sculpt the nebulae around them into dramatic shapes, towering pillars, sweeping arcs, and glowing walls of ionized gas. Some regions sparkle as open clusters, where dozens or hundreds of young stars shine together, still bound to their birth cloud. Others scatter quickly, their members flung apart by gravity, destined to wander the galaxy alone. But stellar nurseries are not only about creation, they are also about destruction. The most massive stars live fast and die young, exploding as supernovas in just a few million years. These blasts send shockwaves tearing through the surrounding gas, disrupting some clouds while compressing others, triggering the next round of star formation. In this way, the galaxy renews itself, one generation of stars giving rise to the next, in an endless cycle of birth, death, and rebirth. For astronomers, these nurseries are windows into our own past. Our Sun, too, was born in such a cloud, 4.5 billion years ago, likely alongside thousands of sibling stars. Today, those siblings are scattered across the Milky Way, too distant to identify. But by observing the stellar nurseries of Andromeda, we glimpse the environment in which our solar system once took shape. We see the origins of the elements that form our world. Carbon, oxygen, iron, all forged in earlier stars, recycled into clouds, and condensed into new suns and planets. From afar, Andromeda's nurseries appear as glowing patches in its spiral arms. Up close, they are worlds of drama and transformation, where light struggles against shadow and where the seeds of future galaxies are planted. They remind us that even in the cold and silence of interstellar space, creation is constant, and somewhere, deep within one of Andromeda's hidden clouds, new stars are flickering to life this very moment, tiny flames against the infinite night. Not all of Andromeda shines with youth. Ancient red stars still burn faintly in the galaxy's core, survivors from the earliest ages of cosmic history. These stars are relics, far older than the Earth, older even than the Milky Way in its present form. Some have been shining for more than 10 billion years, born when the universe was still young, its galaxies just beginning to take shape. They are the quiet elders of Andromeda, glowing with a dim, steady light, reminders of a time when heavy elements were scarce and the cosmos was simpler. Unlike the hot blue giants that blaze fiercely and fade in a few million years, these red stars endure. They are small, thrifty, and remarkably stable. Their nuclear furnaces burn slowly, conserving fuel so efficiently that they will outlive even the present universe. Long after brighter stars have gone dark, these ancient dwarfs will still be glowing tiny embers in the galactic night. In Andromeda's crowded core, billions of these aged stars cluster together, forming a dense reddish bulge. Through telescopes, this region looks warm and golden compared to the bluer outer arms. The color is a clue. Blue stars live short lives, so any galaxy region dominated by red stars is a place where star formation has slowed, leaving behind the survivors of earlier eras. These are the keepers of Andromeda's memory. Each ancient star is a time capsule. Locked inside, their atmospheres are records of the early universe. By studying the chemical fingerprints of their light, astronomers can piece together how galaxies like Andromeda assembled themselves. Many of these stars contain only the simplest elements, hydrogen and helium, with traces of heavier atoms forged in the first generations of supernovas. They bear witness to a time before planets like Earth could form, before carbon and oxygen were plentiful enough to seed life. These old stars also serve as cosmic anchors. Their long lives allow scientists to trace the history of Andromeda's growth. Some belong to populations that formed when the galaxy was young. Others were captured from smaller galaxies that merged with Andromeda, their paths preserved in long orbital loops. By following these stars, astronomers can reconstruct the story of past collisions and cosmic migrations. Imagine drifting within Andromeda's central bulge. The sky would be ablaze with light, not from a few bright suns, but from countless faint ones packed close together. Where on Earth's sky the nearest star beyond the Sun lies 4 light-years away, here the nearest stars might be only a fraction of a light-year apart. Night would never be dark. The heavens would glow with a ceaseless twilight, powered by the combined light of billions of ancient suns. In these elders, Andromeda reveals its continuity. It is also a place of endurance, where stars can persist for almost the entire history of the cosmos. When we look at the reddish glow of Andromeda's core, we are looking not only at light, but at memory, still burning, across the void of time. Orbiting Andromeda are hundreds of globular clusters, dense balls of ancient stars. Each one is like a fossil, carrying the story of the galaxy's earliest days. These clusters are among the most beautiful and mysterious structures in the universe. Imagine a sphere of stars, not scattered loosely like those in our local sky, but packed together so tightly that thousands could fit in a region only a few dozen light-years across. In the core of a globular cluster, the night would blaze with hundreds of suns, so bright and so numerous that true darkness would never fall. For planets within such regions, if they exist, the heavens would be a perpetual jewel box, dazzling with brilliance. Globular clusters are ancient beyond measure. Most formed more than 10 billion years ago, not long after the universe itself emerged from the Big Bang. That means many of the stars within them are nearly as old as time itself. They shine faintly, mostly as red giants and dwarfs, their massive siblings long since gone supernova. Each cluster is like a living museum, preserving the conditions of the early cosmos. Andromeda holds more of these guardians than the Milky Way, at least 500, perhaps more scattered throughout its halo. Some orbit close to the galactic center, while others wander far out in the outskirts, tens of thousands of light-years from the core. They move like satellites, tracing graceful paths through the galaxy's gravitational field, steady companions to the larger spiral they surround. Astronomers study these clusters with reverence, for they hold secrets of Andromeda's formation. The stars within them often contain very few heavy elements, suggesting they were born before galaxies had undergone many cycles of star birth and death. By comparing the chemical signatures and orbits of different clusters, scientists can reconstruct when and how Andromeda grew. Some clusters seem native, formed within Andromeda itself. Others may be immigrants, carried in by smaller galaxies that Andromeda consumed, leaving their starry globes as relics of long-vanished systems. The sheer endurance of these clusters is staggering. While spiral arms shift and dissolve over billions of years, Globular clusters persist, bound tightly by gravity. Their stars are like family members bound together for eternity, resisting the pull of galactic tides. Even when galaxies collide and merge, these clusters often survive the chaos, carried forward into the next age of cosmic evolution. From Earth, we see them only as faint points near Andromeda's disk, invisible to the unaided eye but revealed in detail through powerful telescopes. Up close, their beauty would rival anything else in the galaxy. Dense swarms of ancient suns glittering in a perfect sphere, each star separated by distances still immense, yet unimaginably closer than those in our own quiet neighborhood. Globular clusters remind us that not all of Andromeda's story is written in gas and dust, in the fleeting brilliance of young stars. Some of it is written in longevity, in stability, in the quiet persistence of stellar families that have survived for nearly the entire history of the universe. They are guardians not only of Andromeda's past, but of its future. Witnesses who will remain long after new generations of stars have come and gone. Beyond the visible spiral lies a faint halo of stars, lonely suns drifting far from the core, pulled by the gravity of dark matter into orbits that span millions of years. To most observers, Andromeda appears as a bright disk, a concentrated whirl of starlight framed by delicate arms. But this glowing structure is only the heart of the galaxy. Surrounding it, stretching far into the darkness, is a diffuse halo, an almost invisible sphere of stars scattered like embers carried on a breeze. These stars are not part of the bustling spiral. They wander at great distances, bound to Andromeda's gravity yet isolated from its luminous core. The halo is vast. It may extend nearly 2 million light-years from Andromeda's center, dwarfing the bright disk we see through telescopes. Within it, stars move slowly, tracing orbits that take hundreds of millions of years to complete. To imagine such a path is to imagine a life lived across epochs. Civilizations rise and fall, planets form and erode, while a single halo star completes only a fraction of its journey around the galaxy. Many of these stars are ancient. They were born in smaller galaxies that Andromeda consumed long ago, their orbits stretched and distorted until they became part of the halo. In this sense, the halo is a graveyard and a museum combined, a place where the ghosts of galaxies past still drift. Each faint point of light is a relic, a survivor of cosmic violence, still carrying the story of its origin within its chemical makeup. The density of stars here is low, far lower than in the spiral arms. A halo star may be separated from its nearest neighbor by hundreds of light-years, floating in solitude through the void. If a planet orbited such a star, its night sky would not blaze with countless lights, as in the crowded core of Andromeda. Instead, it would appear almost empty, a dark sky with perhaps one or two faint suns in the distance, a lonely perspective on an immense galaxy. Astronomers study these halo stars carefully, for they hold clues to Andromeda's growth. By mapping their motions, scientists can trace the shape of the galaxy's dark matter halo, the invisible framework that guides their paths. Streams of halo stars often reveal the remnants of entire galaxies stretched thin by Andromeda's pull. The halo, though faint, is one of the best records of the galaxy's long and complex history. Seen from afar, Andromeda's halo would appear ghostly, almost transparent, a whisper of light around a brighter center. But it is real, and it is vast, containing not just stars but globular clusters, dwarf galaxies, and the invisible mass of dark matter itself. It is the unseen body around the galaxy's shining face. The ghostly halo reminds us that galaxies are not defined solely by their brightest features. Much of their true size and substance lies in the faint, the hidden, the quiet. Andromeda's halo is a silent ocean of stars, stretching beyond sight, an invisible reminder of the forces that shape every galaxy in the universe. Andromeda is not alone. More than 30 tiny dwarf galaxies orbit it, each one a satellite, each one a clue to how great galaxies build themselves from smaller parts. To picture these companions, imagine fireflies circling around a lantern. The lantern, bright and steady, is Andromeda itself, while the fireflies are small, fragile galaxies pulled into its gravitational embrace. Some are close, clinging tightly to Andromeda's halo. Others drift much farther out, wandering satellites that still feel its pull across hundreds of thousands of light-years. These dwarf galaxies are much smaller than Andromeda, containing only a few million stars, sometimes even less. Some are little more than loose swarms, irregular in shape, their structures warped by Andromeda's stronger gravity. Others are more compact, appearing as faint, round smudges of light through a telescope. Compared to the trillion suns in Andromeda's core, their populations are tiny, yet each one is a living laboratory of galactic evolution. Many of these companions bear the scars of Andromeda's hunger. As they orbit, tidal forces stretch them thin, stripping stars from their edges. Over time, some will be devoured entirely, their stars torn free to join Andromeda's halo or spiral arms. This process of galactic cannibalism is how giants like Andromeda grow. Each satellite it consumes adds mass, changes its shape, and leaves behind faint trails of starlight, the stellar streams that crisscross its outer halo. The dwarf companions also tell a story of diversity. Some are gas-rich, with new stars still forming in their faint clouds. Others are barren, ancient systems of old, red stars, long past their prime. Some orbit in loose, tilted paths, while others move in an eerie alignment, as if part of a coordinated dance. Astronomers still debate why certain groups of dwarfs cluster together or share similar orbital planes. These patterns may hint at larger forces, perhaps remnants of a single massive collision in the distant past. Among Andromeda's entourage are some familiar names: M32 and M110, two of the brightest dwarf companions, visible even through small backyard telescopes. M32 is a compact elliptical galaxy, unusually dense, as though its outer layers were stripped away by Andromeda long ago. M110, by contrast, is larger and more diffuse, showing signs of ongoing tidal disruption. Each companion offers a glimpse of Andromeda's appetite, its gravity sculpting and reshaping its neighbours over billions of years. For scientists, dwarf galaxies are more than curiosities. They are building blocks. The universe's first galaxies may have resembled today's dwarfs, small, fragile, and numerous. Over time, they merged and coalesced into the spirals and ellipticals we see today. To study Andromeda's companions is to look backward in time, to glimpse the raw material from which giants are made. From Earth, these satellites appear faint, often invisible without powerful instruments. But together, they form a retinue, a living reminder that even the largest galaxies do not stand alone. Andromeda's dwarfs are witnesses, companions, and eventually, sacrifices. Small galaxies drawn inevitably into the story of a larger one. Andromeda has been feasting for billions of years. It has torn apart neighbouring galaxies, scattering their stars into its halo, leaving behind ghostly trails that stretch across intergalactic space. This process may sound violent, and in truth, it is. But it unfolds so slowly, across such enormous spans of time, that it appears almost serene when viewed from afar. To human eyes, the arcs of stolen stars look like delicate brushstrokes across the galaxy, shimmering strands of light tracing the invisible pull of gravity. These streams are the remnants of entire galaxies, stretched thin until their original shapes vanish, their stars becoming part of Andromeda's growing mass. Galactic cannibalism is one of the main engines of cosmic evolution. Large galaxies like Andromeda did not form all at once. Instead, they grew over billions of years by swallowing smaller systems. Each dwarf galaxy that strayed too close was caught, broken apart, and absorbed. The stars, planets, and gas within them became fuel for Andromeda's expansion. Over time, this slow accumulation transformed it from a modest spiral into one of the largest galaxies in the local group. Evidence of these meals is written across Andromeda's outskirts. Observations from wide-field surveys reveal faint stellar streams wrapping around the galaxy in great arcs. Some form loops, encircling the halo like forgotten rings. Others cut across space in long ribbons, still tracing the paths of the doomed galaxies they once belonged to. Each one is a scar, a record of Andromeda's appetite. Among the most striking examples is the giant stellar stream, a vast ribbon of stars extending over 100,000 light-years. It is the remnant of a galaxy that collided with Andromeda not long ago, in cosmic terms, perhaps only a few billion years in the past. Today, its stars are scattered across the halo, their original home erased, their identity absorbed into something larger. The stream is a vivid reminder that galaxies are not static structures, but living, changing systems built from countless mergers. This cannibalism does more than increase Andromeda's size. It reshapes the galaxy's very structure. When a smaller system collides with Andromeda, it stirs the stars within, thickens the galactic disk, and can even trigger bursts of new star formation as gas clouds are compressed. The galaxy that emerges is never the same as before. It is larger, more massive, and marked by the traces of its meal. The Milky Way is no stranger to this process either. Even now, our galaxy is absorbing the Sagittarius dwarf galaxy, its stars forming long tidal tails across our sky. And one day, in the far future, the ultimate act of galactic cannibalism will occur. Andromeda and the Milky Way will consume one another, merging into a single, colossal galaxy. So while the term cannibalism may sound destructive, it is also creative. From the ruins of smaller galaxies, greater ones are born. Andromeda is a monument to this process, a sprawling spiral built from the lives of countless others, its halo haunted by their ghostly trails. Astronomers once puzzled over why Andromeda seemed to contain more old stars than expected. Studies revealed a turbulent history of collisions and mergers, where star formation rose and fell like tides. At first, the mystery was simple. Galaxies like Andromeda, with their broad spiral arms and rich gas clouds, should be thriving with young stars. Andromeda does have stellar nurseries, glowing with blue giants and clusters of newborn suns. But when astronomers looked more carefully, they found something unusual. Compared to the Milky Way, Andromeda seemed to hold a higher proportion of older, redder stars. The balance was off, as though a generation of stars had been skipped. This imbalance became known as the stellar population crisis. Why were there so many ancient stars and fewer young ones than theory predicted? The answer lay not in the quiet present, but in Andromeda's turbulent past. Their histories are punctuated by collisions, sometimes gentle, sometimes catastrophic. When Andromeda collided with smaller galaxies, vast waves of gas were compressed, triggering bursts of star formation. For a time, the galaxy would blaze with new light. But after the storm, the gas supply was often depleted, leaving long periods of quiet where few stars were born. By studying the ages of Andromeda's stars, scientists have pieced together this rhythm. Millions of stars were born in a cosmic firestorm illuminating the galaxy. But once that gas was spent, the rate of new star birth plummeted, leaving behind a population dominated by older survivors. Today, we see the echo of those cycles in the mix of stars. The galaxy still forms new ones, but not at the furious pace of its past. The abundance of older stars gives Andromeda a more subdued glow, especially in its core, where ancient red giants dominate. It is as though we are seeing the galaxy in middle age, still active, but with the memory of its youth written across its stars. For astronomers, this discovery was more than a curiosity. It was a reminder that galaxies are dynamic, living systems. They can flare with creation, then fall quiet, their histories shaped by chance encounters and cosmic accidents. Andromeda's population crisis tells us that even giants are vulnerable to the whims of their environment. The Milky Way, too, has its rhythms. Our own galaxy is currently in a relatively calm phase of star formation, but in the future, collisions with smaller companions, and eventually with Andromeda itself, will ignite new surges. The crisis in Andromeda is, in truth, not a failure, but a natural stage in a galaxy's life cycle. When we look at Andromeda today, we see a galaxy not frozen in perfection, but caught in transition. Its stars are not evenly spread across time. They come in waves, in generations, each one a reflection of past collisions and cosmic events. The stellar population crisis is not a flaw, it is a story. A story written in the ages of stars, a story that tells us galaxies are alive with change. Across Andromeda, dying stars explode in brilliant supernovas. Each one briefly outshines the galaxy itself, seeding space with heavy elements that will form future planets. Supernovas are the grand finales of stellar life, spectacular detonations that occur when a star reaches the end of its fuel. In Andromeda, with its trillion suns, such events are not rare. Somewhere within its spiral arms, at any given moment, a massive star is nearing its final breath, building toward a cosmic firework that will change its surroundings forever. For a brief time, a single exploding star can blaze brighter than the combined light of billions of its neighbours. To anyone watching from a nearby world, it would appear as a sudden second sun, rising unbidden in their skies. The glow would last for weeks, sometimes months, before fading back into darkness. Yet, the legacy of that explosion would remain for eternity. Supernovas are more than spectacles. They are creators. In the heart of a massive star, nuclear fusion produces lighter elements, hydrogen into helium, helium into carbon, oxygen, and so forth. But the heaviest elements, like iron, gold, and uranium, are forged only in the furious violence of a supernova. When the star tears itself apart, these precious elements are cast into space, mixing with interstellar gas. In time, they become the raw materials for new stars, new planets, and perhaps new life. Every atom of calcium in your bones, every atom of iron in your blood, was once created in such a cataclysm. To say we are made of stardust is not poetic exaggeration. It is scientific truth. And in Andromeda, as in the Milky Way, supernovas ensure that the cycle continues, that the galaxy remains enriched with the building blocks of worlds. Some of these explosions leave behind dense remnants. Neutron stars, the collapsed cores of massive suns, where matter is squeezed so tightly that a teaspoon would weigh billions of tons. Others give birth to black holes, silent predators that lurk invisibly, their gravity capturing anything that strays too close. In this way, each supernova alters the landscape of the galaxy, creating both destruction and possibility. Andromeda has given us one of the most famous supernovas in recorded history. In 1885, astronomers observed a sudden brightening in the galaxy, a point of light so intense it rivaled the core itself. This was supernova 1885 amperes, the first ever detected beyond the Milky Way. To the astronomers of the 19th century, it was a revelation, proof that the universe was filled with distant explosions, far grander than anything in our own skies. Though Andromeda lies millions of light years away, its fireworks still reach us, their light crossing the void to tell the story of death and rebirth. When we observe these distant detonations, we are not only studying the fate of stars, but glimpsing the future of our own galaxy. One day, massive stars in the Milky Way will end the same way, seeding our corner of the cosmos with the ingredients for worlds yet unborn. Supernovas remind us that endings in the universe are never absolute. They are beginnings in disguise. In every flash of destruction, there is renewal, and in every spark of light scattered into the dark, there is the promise of life yet to come. Besides its central giant, Andromeda contains many smaller black holes scattered throughout its disk. They are the silent leftovers of massive stars, unseen but powerful. Each of these stellar mass black holes began life as a massive star, dozens of times larger than our Sun. When their nuclear fuel was exhausted, their cores collapsed under the weight of gravity, crushing matter into a point so dense that nothing, not even light, could escape. The star's outer layers were blown away in a final supernova, leaving behind only the invisible remnant. What remains is a gravitational well, dark and quiet, marking the graves of suns that once burned fiercely. In Andromeda, with nearly 1 trillion stars, such events have happened countless times. Astronomers estimate that the galaxy may contain millions of these smaller black holes, spread across its spiral arms, hidden within star clusters, or drifting through the halo. They are nearly impossible to detect directly, for they emit no light of their own. Instead, their presence is revealed only when they interact with their surroundings, when a star wanders too close, or when gas falls inward, heating up and shining in X-rays before vanishing into the dark. Some of Andromeda's black holes live in pairs, locked in orbit with a companion star. These systems are known as X-ray binaries. As the black hole pulls matter from its partner, the gas forms a glowing disk around the unseen object, radiating energy as it spirals inward. Through these signals, astronomers can trace the existence of black holes scattered across Andromeda's disk, each one a hidden predator feeding quietly in the night. Others drift alone, silent wanderers that may never reveal themselves. If one passed near our own solar system, we would not see it, but we would feel it, as its gravity bent the orbits of planets and asteroids. In Andromeda, such wanderers are ghosts, influencing their surroundings subtly, yet leaving no visible mark. The most intriguing possibility is that some of Andromeda's black holes are larger than stellar remnants, but smaller than the central supermassive giant. These so-called intermediate mass black holes may lurk in star clusters or dwarf galaxies absorbed by Andromeda. Their existence is still debated, but if real, they could be stepping stones, the seeds from which supermassive black holes grow. Taken together, these black holes form an invisible population, as much a part of the galaxy as its bright stars. They remind us that Andromeda is not only a place of light and creation, but also of shadow and endings. The balance of the galaxy depends on both. The radiant stars that shine, and the dark remnants that wait silently among them. From Earth, we see only Andromeda's glowing face, its spirals, its dust, its luminous core. But hidden within that beauty are countless black holes, neighbors we will never meet, shaping their environments in silence. They are reminders that the universe is not defined only by what is visible. Much of its story lies in the unseen, in forces that whisper rather than shout, in power cloaked by darkness. For years we thought the Milky Way and Andromeda were close in size. Now we know Andromeda is wider, heavier, and more sprawling, yet the two galaxies are still destined to merge. For much of the 20th century, astronomers believed that our home galaxy might rival Andromeda in scale. Both appeared to be grand spirals, each with hundreds of billions of stars, each with sprawling arms and a central bulge. The Milky Way, hidden from our view by its own dust and gas, was difficult to measure with precision. Andromeda, visible from the outside, seemed only slightly larger, but as our tools improved, a clearer picture emerged. And with it, the revelation that Andromeda's size was greater than we imagined. The Milky Way is vast, around 100,000 light-years in diameter, with perhaps 300 to 400 billion stars. But Andromeda stretches farther. Its visible disk more than 200,000 light-years across, with nearly 1 trillion stars. Its mass, too, is greater. Not just from the stars we can see, but from its immense dark matter halo, which envelopes it like an unseen shell. Andromeda is not only wider, but heavier, outweighing the Milky Way by a considerable margin. This difference is not a rivalry so much as a reflection of cosmic variety. Galaxies come in many forms, some dwarfs, with only a few million stars, others giants with trillions. Andromeda and the Milky Way are both among the largest in our local group. But Andromeda stands as the heavyweight, its arms sweeping wider, its central black hole more massive, its population of clusters and companion galaxies richer. Yet size does not diminish significance. From within the Milky Way, our galaxy feels infinite. Its spiral arms, stretching thousands of light-years, are more than enough to cradle worlds like ours. The fact that Andromeda is larger reminds us only that there is always something greater, something beyond. The scale of the universe is a ladder with no end, each rung revealing a larger perspective. The comparison between the two galaxies is also a glimpse into the future. Their halos already overlap, tugging at one another across the void. Gravity is pulling them closer, and in about 4 billion years, they will meet. At that time, Andromeda's greater mass will play a crucial role in shaping the outcome. The Milky Way may spiral into its embrace, its stars flung into new orbits as the two merge into a single colossal system. Some scientists already call this future galaxy Milkomeda, a union larger and brighter than either alone. So, while Andromeda surpasses the Milky Way in size and mass, the two are not competitors but partners in a cosmic dance. Their fates are linked, their histories intertwined. To compare them is to glimpse not rivalry, but destiny. When we look at Andromeda and recognize its grandeur, we are not diminished. We are reminded that our galaxy, too, is part of something greater, that even the vast Milky Way is just one piece of a story still unfolding across the stars. In 4 billion years, Andromeda and the Milky Way will meet, not in a violent crash, but in a slow interweaving of stars, stretching across hundreds of millions of years. To imagine this event is to picture two vast oceans of light drifting toward each other across a silent void. Each galaxy is enormous, yet so diffuse that when they finally overlap, the stars themselves will almost never collide. Instead, they will pass by one another like dancers in an intricate waltz, their paths altered, their orbits reshaped, but their individuality intact. It is gravity, not impact, that will weave the two into one. At first, the galaxies will approach cautiously, like partners circling on a grand stage. Their outer halos are already touching, faint threads of dark matter and scattered stars blending invisibly. As they draw closer, tidal forces will begin to distort their elegant spirals. Long tails of stars will be drawn outward, flung into space like ribbons pulled by unseen hands. From afar, it will look as though the galaxies are stretching toward one another, their shapes unraveling as they embrace. Over hundreds of millions of years, this slow-motion dance will continue. Andromeda will pass through the Milky Way, overshoot, and then be drawn back again, their mutual gravity ensuring repeated encounters. Each pass will stir the stars, triggering bursts of new star formation as gas clouds collide and compress. For a time, both galaxies will blaze brighter than ever before, their spiral arms lit with newborn clusters. From the perspective of Earth, if Earth still exists by then, the night sky will be transformed. Andromeda, now a faint smudge, will swell until it dominates the heavens, filling the horizon with spirals of light. As the galaxies overlap, the view would be otherworldly. Arcs of stars stretching across the entire sky, glowing clouds of gas igniting into brilliant nebulae. It would be a cosmic spectacle, unfolding not over days or years, but across epochs. Despite the grandeur, the solar system may survive relatively unscathed. The odds of another star passing close enough to disrupt our sun are slim. Still, the orbits of planets could shift, and our system might be flung into a new position within the merged galaxy. Some stars may even be ejected entirely, cast into the emptiness between galaxies, destined to drift forever in the dark. Eventually, after countless passes and slow spirals inward, Andromeda and the Milky Way will settle into a single, larger structure, no longer graceful spirals, but a vast elliptical galaxy, smoother, rounder, and brighter than either alone. Astronomers already have a name for it, Milkomeda. Though distant in time, this collision is certain. It is written in the mathematics of motion, confirmed by measurements of Andromeda's approach. And so, when we look at that faint smudge in our night sky, we are also looking at the future, at a meeting already set in motion billions of years ago, a slow and inevitable merging of two great star systems. When the collision ends, the two galaxies will merge into a single giant elliptical system. Astronomers call it Milkomeda, a cosmic union that will reshape our night skies forever. This transformation will not be sudden, but gradual, unfolding over billions of years. First, the Milky Way and Andromeda will swirl through one another in repeated passes, like tides surging in and out. Each encounter will tug at their shapes, pulling long streams of stars into space, warping their graceful spirals into strange and tangled forms. By the time the merging is complete, their familiar structures will be gone, replaced by a smooth, rounded giant, a galaxy larger and brighter than either of its parents. The resulting Milkomeda will likely be an elliptical galaxy, a sprawling oval of stars without the delicate arms that once defined both spirals. Ellipticals are common in the universe, especially in regions where galaxies crowd together and collide. They are massive, containing trillions of stars, and they shine with the glow of older, redder populations. This is Andromeda and the Milky Way's destiny, to surrender their spirals and become something altogether new. The night sky, for any survivors within the merged galaxy, will be breathtaking. Where once we saw the faint band of the Milky Way stretching across Earth's heavens, future skies will blaze with stars in every direction. Nebulae, superclusters, and arcs of starlight will appear brighter and closer. The galaxy that results will be home to twice as many stars, perhaps 2 trillion in total. Each one a tiny lantern in the cosmic dark. For worlds orbiting these suns, night will be a perpetual festival of light. But this union is not merely about beauty. It is also about renewal. Collisions between galaxies can compress vast clouds of gas, igniting waves of star formation. For a time, Milkomeda will glow with newborn stars, its heart blazing brighter than ever before. In this way, Milkomeda's life cycle will mirror the lives of galaxies everywhere: bright youth, turbulent middle age, and a long, quiet maturity. The merger will also reshape the orbits of stars and planets. Some will be cast into new trajectories, spiraling closer to the core. Others may be flung outward, ejected into intergalactic space. Our own solar system may survive, but it may also find itself in an entirely new region of the galaxy, orbiting paths we cannot yet predict. Astronomers take comfort in knowing this future is not dangerous in the way we might first imagine. Instead, the merging is more like a blending, 2 great clouds of light and gravity mingling into one. The true drama is not in destruction, but in transformation. Milkomeda will be a monument to time, a symbol of the universe's ability to reshape itself endlessly. From 2 great spirals will come one immense system, larger, heavier, and more luminous than either alone. And though none of us will live to see it, we can look up tonight at the faint glow of Andromeda and know we are gazing at our galaxy's future face. Though stars rarely collide, planetary systems may be thrown into chaos. Worlds could be ejected into intergalactic space, while others might find new suns to orbit. When Andromeda and the Milky Way begin their long embrace, the sheer distances between individual stars will protect most from direct impact. But while stars themselves will pass safely, the delicate orbits of planets around them may not be so fortunate. Gravity is a subtle force, yet when entire galaxies collide, it acts like a restless tide, pulling and tugging on the paths of countless worlds. Consider our own solar system. The sun will continue to shine, steady in its nuclear rhythm, but as Andromeda's gravity presses in, the orbit of our star may shift. Perhaps we will be drawn closer to the core of the new galaxy, or perhaps we will drift outward into the vast halo. The planets, too, may feel the pull. Their orbits, now so precise and stable, could be tilted or stretched. Some may be cast adrift, torn away from their parent star, becoming lonely wanderers in the dark. These rogue planets, flung free by the collision, would drift between galaxies, unbound to any sun. Cold, lightless, and solitary, they would travel endlessly through the cosmic night. Yet even these lost worlds would carry the history of their home galaxies within them, silent witnesses to the grand merger that set them free. Not all consequences would be destructive. Some planetary systems could find themselves in entirely new neighborhoods, orbiting alongside unfamiliar stars. In rare cases, a planet might even be captured by another sun, exchanging one sky for another. Imagine a world where, after billions of years orbiting one star, its people suddenly find a new sun blazing overhead, a cosmic migration written into the very orbits of their home. The merging of galaxies could also spark bursts of star formation, as clouds of gas collide and compress. New suns would be born, surrounded by new planets. The future Milky galaxy may be richer in worlds than either Andromeda or the Milky Way alone. For any civilizations that might arise or endure, the night skies of these planets would blaze with more stars than ever, the heavens transformed by the merger. Of course, our own planet may not survive to witness this future. Long before the collision is complete, the Sun will exhaust its fuel and swell into a red giant, consuming Mercury, Venus, and perhaps Earth itself. But if humanity or its descendants endure, scattered among distant stars, they may watch the union unfold from new homes. For them, the planetary consequences would not just be theoretical. The thought is both humbling and awe-inspiring. Galaxies merge over billions of years, reshaping themselves with patience beyond imagination. Planets, fragile and small, are caught in the tides of this cosmic ocean. The planetary consequences of Andromeda's approach remind us that while stars may be steady, the worlds they cradle live precarious lives, their fates tied to the larger story of galaxies themselves. If life exists on planets within Andromeda, their skies must blaze with stars. From their perspective, the Milky Way would appear as a faint, ghostly neighbour across the darkness. Imagine standing on a world orbiting one of Andromeda's trillion suns. Perhaps it circles a modest yellow star, much like our own sun. When night falls on that world, the sky would erupt into brilliance. The galaxy's dense spiral arms would arch overhead, glowing rivers of starlight woven with dark streaks of dust. Star clusters would sparkle like scattered jewels, nebulae would bloom in soft colours, and the galactic core would blaze as a golden fire, far brighter than the faint band of the Milky Way we see on Earth. For any eyes gazing upward, the sky would never truly be dark. To such beings, the Milky Way would be the faint smudge, a soft oval of light, distant and mysterious, hanging in their sky just as Andromeda hangs in ours. Their astronomers, if they exist, might puzzle over its nature. Is it a nearby cloud of stars, a strange nebula, or could it be an entire galaxy, equal in grandeur to their own, shining from across the cosmic void? Their questions would mirror ours, their wonder echoing ours across the gulf of space. From their perspective, the approach of the Milky Way would also be visible. Over millions of years, the ghostly blur in their sky would grow larger and brighter, its shape slowly resolving into a spiral. Generations of alien skywatchers might record the change, perhaps even predicting the collision long before it happens. The anticipation of that cosmic meeting could become part of their myths, their science, their collective imagination. But beyond the grand view, life within Andromeda would also feel the galaxy's scale more intimately. In its dense central regions, stars are packed so closely that their nights would glow with hundreds of suns. For civilizations in those crowded zones, navigation across the stars might be easier. Solar systems lying only a few light years apart, their skies filled with potential destinations. Conversely, in the faint halo, alien worlds might orbit in solitude, their skies dark and lonely, their nearest stellar neighbours impossibly far away. If intelligent life does exist there, their understanding of the universe would be shaped by this perspective. Where we see Andromeda as a mystery in the distance, they would see it as home. Where we view the Milky Way as everything we know, they might see it as a distant puzzle waiting to be solved. Perhaps their scientists, peering through powerful instruments, already know about us, the faint signals of our sun, lost among the trillion others, barely whispering across the void. It is a humbling thought that as we wonder about them, they might wonder about us. Two galaxies, two perspectives, each one looking across millions of light years toward the other. And in both, life, if it exists, may look upward with the same question. Are we alone? Where does Andromeda end? Its stellar halo fades into invisibility, and its dark matter halo continues even farther. In truth, the boundary is less an edge and more a gradual blending into the cosmic web. When we think of boundaries, we imagine clear lines, the shoreline where ocean meets land, the horizon where earth meets sky. But galaxies are not so simple. Their light does not stop abruptly. Instead, it thins, becoming faint, then invisible, until only darkness remains. Yet even then, the galaxy is not truly gone. Its influence continues in the form of gravity, pulling stars, gas, and even entire galaxies into its sway. For Andromeda, the visible disk stretches about 200,000 light-years across, a graceful spiral glowing with 1 trillion suns. But beyond that lies its stellar halo, a sparse sphere of drifting stars, globular clusters, and faint streams left over from past mergers. This halo extends nearly 2 million light-years, far larger than the luminous spiral we usually picture. If our eyes were sensitive enough, Andromeda would not appear as a faint smudge in the sky, but as a vast, diffuse glow spanning a large part of the heavens. Even this is not the true edge. Wrapped around Andromeda is a dark matter halo, an invisible cocoon of mass stretching millions of light-years farther still. It cannot be seen, but its presence is undeniable, shaping the motions of stars and bending the paths of satellite galaxies. In this sense, Andromeda has no sharp boundary. Its body fades gradually into the greater structures of the universe, overlapping with the Milky Way's own dark halo, blending into the threads of the cosmic web. This blending challenges our intuition. When does Andromeda stop being Andromeda and start becoming part of the local group, or the Virgo supercluster beyond? The truth is that galaxies are not isolated islands. They are knots in a larger tapestry, bound together by dark matter filaments, constantly exchanging matter and energy with their surroundings. The edge is not a place, but a gradient, a transition zone where identity dissolves into connection. For astronomers, defining this boundary is both practical and philosophical. To measure a galaxy's size, one must decide where to draw the line: at the edge of visible stars, at the limits of the halo, at the farthest reach of gravitational influence. Each choice tells a different story, each number a different truth. In this way, Andromeda is both 200,000 light-years wide and millions, both a finite spiral and a near-endless structure fading into infinity. From Earth, this ambiguity only adds to its wonder. The faint glow we see is merely the brightest part of something immeasurably larger. Its true edge lies beyond sight, beyond even imagination, fading into the scaffolding of the cosmos itself. And so, asking where Andromeda ends is much like asking where the universe itself ends. The answer is not a sharp border, but a reminder that everything we see is part of something greater, connected across space and time, woven into the endless fabric of the cosmic web. Andromeda is not isolated. It is tied by threads of dark matter and gas to the rest of the local group, bound into the great cosmic web that shapes the universe. When astronomers look at the larger scales, the universe does not appear random. Instead, galaxies form patterns, strung along vast filaments that stretch like gossamer threads across the dark. Between these threads lie enormous voids, regions almost empty of matter, like bubbles in cosmic foam. Together, these filaments and voids form what we call the cosmic web, the grand architecture of the universe. Andromeda, like the Milky Way, sits within one of these filaments. It is not a lonely traveller drifting through emptiness, but part of a network, a knot of matter where threads converge. The local group, our small collection of galaxies, is one of many such knots, linked to neighbouring groups by invisible bridges of dark matter. Through these bridges flow gas and the faint pull of gravity, guiding galaxies into clusters and clusters into superclusters. The cosmic web is invisible to our eyes, but not to our instruments. Astronomers trace its presence by mapping the distribution of galaxies across billions of light-years. What emerges is a structure both delicate and immense. Threads spanning hundreds of millions of light-years, glowing faintly with the light of galaxies strung like beads along a string. Andromeda's place within this web is secure, anchored by its dark matter halo, which itself connects to the halos of other galaxies nearby. This connection matters. Gas flowing along the web replenishes galaxies, fueling new star formation. Without these cosmic supply lines, galaxies would exhaust their reserves and grow dark. Andromeda shines today because, across billions of years, it has been fed by these hidden rivers. Even now, faint streams of hydrogen trickle into its disk, invisible to us but vital to its survival. The cosmic web also shapes destiny. The local group, which includes Andromeda, the Milky Way, and dozens of smaller companions, is drifting toward the Virgo cluster, the nearest large concentration of galaxies. In time, trillions of years in the future, these motions will draw groups together, weaving them into larger and larger structures. What begins as a filament of galaxies will end as a gravitationally bound cluster, a denser knot in the universal web. From a human perspective, these timescales are unfathomable, but to the universe they are natural rhythms. Galaxies flow along filaments like leaves carried by a current, gathering where the streams converge, fading where the currents thin. Andromeda is one such leaf, vast beyond comprehension, yet still part of something greater. To gaze at Andromeda, then, is to see not just a galaxy, but a connection point. Its light, its stars, its future merger with the Milky Way, all are shaped by the unseen web that stretches across the cosmos. The galaxy is not alone, and neither are we. We are part of a vast design, a universe stitched together by threads too fine to see, yet strong enough to hold everything that exists. Zooming out, Andromeda and the Milky Way are just two galaxies in a much larger structure. The Virgo supercluster, a sprawling city of galaxies bound together by gravity. From our perspective on Earth, galaxies often feel like solitary islands. We speak of the Milky Way, of Andromeda, of their stars and planets, as though each floats alone in space. But when astronomers map the cosmos on its grandest scales, another truth emerges. Galaxies are social. They gather into groups, groups into clusters, and clusters into immense superclusters. These superclusters are the cosmic metropolises of the universe, vast cities where galaxies are the glowing towers and filaments of dark matter are the streets between them. The Virgo supercluster is our home metropolis. Stretching more than 110 million light-years across, it contains thousands of galaxies, spread across a vast expanse of space. At its heart lies the Virgo cluster itself, a dense knot of more than 1,000 galaxies bound tightly together. The local group, home to both Andromeda and the Milky Way, sits on the outskirts, orbiting like a suburb circling a city centre. Though distant from the core, we are still part of this immense gravitational family. To grasp its scale is nearly impossible. Imagine a map where each dot is not a star but an entire galaxy. On that map, the Milky Way and Andromeda are two small points, separated by just a sliver. Together with dozens of dwarf galaxies, they form the local group. The local group, in turn, is one neighbourhood in the outskirts of Virgo's vast territory. Beyond Virgo lie other superclusters, other cosmic cities, forming an even larger structure, the observable universe itself. The supercluster binds its members through the unseen threads of dark matter. In this way, Virgo is more than a collection of galaxies. It is a coherent system, an empire of light stretching across hundreds of millions of light-years. For Andromeda, this place within Virgo provides context. It is not merely a large galaxy, not merely the Milky Way's future partner, but one citizen among thousands in a greater community. Its mass, its mergers, its halo, all are part of the same dynamics that govern galaxies across the supercluster. Gas flows along filaments into clusters. Collisions spark bursts of creation. Groups orbit one another in slow gravitational dances. The story of Andromeda is, in truth, a local chapter of the supercluster's grander tale. From Earth, we cannot see Virgo's full expanse with our eyes, but telescopes reveal its richness. Great spirals, giant ellipticals, delicate dwarfs, all strung across the night in silent harmony. To look outward at Virgo is to see our cosmic address written clearly. We are not just in the Milky Way, not just in the local group, not just neighbours of Andromeda. We are residents of a supercluster, one district in the sprawling city of the universe. And so, when we gaze at Andromeda, we glimpse not only a nearby galaxy, but our place in something far larger. The Virgo supercluster is the stage, and Andromeda one of its brightest players, a reminder that even giants are part of greater constellations of light. Even this supercluster is only a piece of something greater. Andromeda is part of the Laniakea supercluster, a gravitational continent of galaxies stretching across hundreds of millions of light-years. The name Laniakea comes from Hawaiian, meaning immense heaven. It is an apt description, for no word better conveys the sheer scale of this structure. Within its borders lie more than 100,000 galaxies, each with billions or trillions of stars. Taken together, it is a continent of light, sprawling across 500 million light-years, bound not by geography, but by gravity, the invisible force that gathers galaxies into shared motion. Andromeda, the Milky Way, and the rest of the local group are tiny citizens of this enormous realm. Our neighborhood, so vast to us, is just a single district within Laniakea's cosmic landscape. To truly imagine it, one must zoom out far beyond individual stars, beyond even galaxies, until galaxies themselves appear as dots sprinkled across a map. On such a scale, Laniakea becomes visible, an immense basin of gravity where galaxies flow like rivers toward the center, drawn into the great attractor, a mysterious region whose pull shapes the motion of our entire supercluster. What makes Laniakea remarkable is not only its size but its coherence. Though the universe is expanding, galaxies within this supercluster move together. Astronomers mapped these flows by tracing the velocities of thousands of galaxies, finding that they all stream toward the same region of space. It is as if the universe itself were an ocean, and Laniakea one of its great tides. For Andromeda, this connection places its story into an even broader context. Its halo, its collisions, its future merger with the Milky Way, all of these unfold within the larger framework of Laniakea. Just as a city shapes the lives of its citizens, the supercluster shapes the lives of its galaxies, guiding their growth and interactions across billions of years. Yet even Laniakea is not the ultimate boundary. Beyond it lie other superclusters, other gravitational continents, strung together across the cosmic web. Each is vast beyond comprehension, and yet each is just one thread in a tapestry that stretches across the observable universe. To contemplate this is to confront the scale of existence itself. That Andromeda, immense as it seems, is only one voice in a choir of uncountable galaxies, singing across the dark. From Earth, we see almost none of this directly. The night sky reveals only a handful of galaxies with the naked eye, and even through telescopes, we see them as isolated points. But the truth is that we are connected to an empire of unimaginable size, a realm where Andromeda is both vast and small at once. The Laniakea supercluster reminds us that every galaxy is part of something greater. And when we look at Andromeda, glowing faintly in the dark, we are not just seeing a neighbor across the void. We are seeing a citizen of an immense heaven, one thread in the boundless fabric of the cosmos. By measuring Andromeda, we learn about our own galaxy. Its stars, its halo, its dark matter all mirror the Milky Way, offering a reflection we cannot see from within our own home. The Milky Way is vast, but from inside it, our view is limited. We see only narrow glimpses, the band of starlight across the night sky, the scattered clusters, the veils of dust that obscure the core. It is like trying to understand a forest while standing among its trees. Andromeda gives us something different, a vantage point from the outside. It is the nearest large spiral galaxy, tilted at just the right angle for us to see its arms, its bulge, its halo. In its light, we find a mirror of what our own galaxy must look like to others. By studying Andromeda's structure, astronomers learn what to expect in the Milky Way. Its trillion stars, organized in spiral arms, resemble the arrangement we suspect in our own galaxy. Its dense central bulge, glowing golden with ancient stars, reflects the one hidden behind the dust in our skies. Even its dark matter halo, detected by the way stars move in its outskirts, teaches us how to map the invisible framework around the Milky Way. Each discovery about Andromeda sharpens our understanding of home. The galaxy also reveals how spirals grow and change. Its stellar streams, remnants of galaxies consumed long ago, show us how mergers shape a galaxy's halo. Its star-forming regions demonstrate how gas flows along spiral arms, collapsing into clusters. Its population of old stars tells us how bursts of creation alternate with long quiet periods. Each of these lessons applies not only to Andromeda but to us. They explain why the Milky Way looks as it does and how it will evolve in the future. Perhaps most importantly, Andromeda reminds us of our galaxy's destiny. Its slow approach, measured carefully over decades, confirms that we are on a collision course. By watching Andromeda's motion, astronomers can predict how the merger will unfold, what kind of galaxy will result, and how the process will reshape the night sky. In a sense, Andromeda is both our teacher and our future, a companion whose path is tied to ours. The study of Andromeda has also pushed the limits of human technology. From the first telescopic glimpses centuries ago to the precise measurements made by the Hubble Space Telescope and the Gaia mission, our tools have grown in step with our curiosity. Each improvement has revealed new details, faint halos, subtle motions, hidden populations of stars. In Andromeda, science finds both challenge and reward. But beyond the data, there is also perspective. To look at Andromeda is to see not just another galaxy, but a reminder of scale. Our entire world, our Sun, our Milky Way, are just one small part of a larger whole. And yet, by studying this neighbour, we begin to understand not only where we are, but what we are part of. Andromeda teaches us that knowledge comes not only from looking inward, but from looking outward, from seeing ourselves reflected in the light of others, even across millions of light years. Andromeda is not just a galaxy. It is a reminder of scale, of time, of cosmic destiny. To know its size is to glimpse our future, our place, and the infinite expanse that holds us all. For most of human history, that faint smudge in the sky was a mystery. Was it a cloud within the Milky Way, a cluster of stars too distant to resolve, or something else entirely? Now we know the truth. It is another great galaxy, larger than our own, vast beyond imagination. To measure Andromeda is to confront numbers so large they almost lose meaning. Trillions of stars, millions of light years of reach, a halo that fades into invisibility. These are figures not meant to be memorized, but to be felt. Reminders of the immensity of the cosmos. Andromeda also offers a lesson in patience. Its light takes 2.5 million years to reach us. Every time we look at it, we see not its present, but its past, a portrait painted long before humanity walked the earth. In this way, Andromeda is both near and impossibly far. We know it will one day merge with the Milky Way. Yet that event lies billions of years in the future. Galaxies move at their own pace, slower than any human measure, teaching us humility in the face of cosmic time. Its story is also our story. The Milky Way and Andromeda are partners in a dance already underway, drawn together by gravity. Their merger is inevitable, their destinies intertwined. To look at Andromeda is to look at the future of the night sky, at a vision of what our galaxy will become. The stars we see there today may one day be our neighbours, their light mingling with ours in a shared new home. But perhaps the greatest perspective Andromeda offers is one of belonging. We often think of ourselves as small, fragile, isolated, a single species on a single planet orbiting an ordinary star. Yet here, across the void, lies a galaxy of unimaginable size, connected to us not only by gravity but by kinship. Its stars are like ours. Its planets may host life like ours. Its future is bound to ours. In the end, Andromeda is not other. It is part of the same universe that cradles us all. To measure it, to name it, to imagine its size, is to see more clearly our own place in the cosmos. We are not the center, but neither are we lost. We are participants in something vast, ancient, and beautiful. Andromeda, glowing faintly in the night sky, is a reminder of that truth. It is more than a galaxy. It is a mirror of destiny, a beacon of scale, a symbol of connection. And when we let its light into our minds, we glimpse not only the universe beyond, but the infinite beyond within ourselves. As we come to the end of our journey tonight, let us pause and remember what we have seen. Andromeda, our nearest great neighbor, is not a simple smudge in the sky. It is a galaxy more than 200,000 light-years wide, holding nearly 1 trillion stars, countless worlds, and mysteries that stretch into the invisible realms of dark matter and the cosmic web. We traveled through its spiral arms, past its dusty veils and stellar nurseries, into the heart where a supermassive black hole anchors its glowing core. We traced the streams of stars that tell of its cannibalistic past, and we wandered into its halo, its dwarf companions, and the faint threads that tie it to the Virgo supercluster and the vast Laniakea beyond. In Andromeda, we saw not just another galaxy, but a reflection of our own, a mirror by which we understand the Milky Way, and a prophecy of the future we will one day share. And above all, we saw perspective. To know Andromeda is to know scale. To measure time in billions of years, distances in millions of light years, and yet still feel the connection that binds us across the void. It reminds us that even in the vastness of space, we are part of something larger, something luminous, something infinite. As you drift toward rest, carry with you a sense of gratitude for the chance to be alive in a universe so immense and beautiful, for the gift of awareness that lets us look outward and wonder, and for the reminder that we are all participants in a story written across the stars. Good night, traveler. May your dreams be filled with galaxies.